consider the waves 4, we have y is equal to sine x and y is equal to sine x plus 45 degrees. So we are going to consider that, and then we describe the transformation. So in this case, this is what we have. We want to describe the transformation. In what we have been having here for the stretch, we have been having cases whereby, for example, we have y is equal to sine x, and we have another one, y is equal to 2 sine a half x. In this case, as you can see here, we have x plus 45 degrees. So we also want now to be able to describe this kind of transformation. What transformation is going to map maybe y is equal to sine x plus 45 degrees onto y is equal to sine x, or vice versa. So in this case again, we need to draw the two graphs, that is the two waves on the same axis. So for this, we can have our range up to 540, whereby we talk of 0, 45 up to 540 degrees. So we can have it from 0 degrees to 540 degrees, and we are going to use 45 as the range. So in this case again, we'll have the values of x. We can have x degrees. So we can start with 45, then we move on to 90, we move on to 135, then we move on to 180, 225, plus 45, we get 270, 270, we add 45, we get, that is 315, again plus 45, we get 360, then we can move on up to 540, so we have 360 again plus 45, we have 405, we add again 45, we have 450, we add again 45, we get 495, then we add 45 again, we get 540. So that's what we have. So in this case, because we are plotting the two waves on the same axis, we can have this one whereby y is equal to sine x. So we first find this, y is equal to sine x. So this is our x. We get y is equal to sine x, y is equal to sine x. So in this we have sine 45. We can write it to one decimal place, whereby we have 0.7. We have sine 90, which is 1.0. We have sine 135, that is 0.7. Sine 180, which is 0. We have sine 225, that is negative 0.7. Sine 270, which is negative 1.0. We have sine 315, which is negative 0.7. We have sine 360, which is 0.0. Then we have sine 405, which is 0.7. Sine 450, which is 1. We have sine 495, which is 0.7. And finally, we have sine 540, which is 0. That is for the first part. Then we can also include the other part, whereby we have sine x plus 45. So here we can have x plus 45 degrees. X plus 45 degrees. So in this case, we'll be adding 45 plus 45. Here we get 90. Then 90 plus 45, we get 135, plus 45, 180, we get 225, 270, 315, 360, 405. Then we get 450, that is for x plus 45 degrees. Then we get 495, 540. Then finally we have 540 plus 45, that is 585. Then here we come and get y is equal to sine whatever we've gotten here, so that we can just have one table for the data. So here we are going to have y is equal now to sine x plus 45 degrees. Again, on the other side here we have y is equal to sine x plus 45 degrees. So in this case, now we want to find the sine for this. Sine 90, we have it here, which is 1.0. 135, we have 0.7. 180, we have 0.0. 225, negative 0.7. 270, negative 1.0. 350, negative 0.7. We have 0.0. We have 0.7. Then for 450, we have 1.0. 495, 0.7. 540, we have 0.0. Finally, we have sine 585, which is negative 0.7. Then after having that, we need now to plot. We need to plot, whereby for y is equal to sine x, we consider this. Then for the other one, we consider that one. We consider this for sine x. Then sine x plus 45 degrees, we consider that. So we need to plot now the waves. We plot the graphs on the same axis. Then we are going to describe the transformation. So in this again, we have the highest value being 1. We have 1 as the highest. So we'll have the following. We have our y-axis, then we have the x-axis. We have our x-axis here. So here we have the highest being 1, so we can have 0.51, 0.51. This is 1, this is 0.5, this is our 0, negative 0.5, and negative 1. Then on this side again, we have from 0, we needed to start with 0 before we go to 45. So we have from 0 to 540. 3, 4, 5, 6, 9, 10. So we have this as 45. We have 45 degrees. We have 90 degrees. 135, 180, we have 225, we have 270, we have 315 degrees, we have 360 degrees, we have 405 degrees, then we have 450 degrees, we also have 495 degrees, and finally 540 degrees. Then now we need to plot those points. We need now to plot the points. So in the first one, we have for y is equal to sine x. So we need to start with the 0. So we needed to start with x. We earned that x degrees when it is 0 degrees. Then again we have here y is equal to sine x. Then we have here x plus 45 degrees. And finally we have y is equal to sine x plus 45 degrees. So in this we have 45 degrees. So we have sine 45 degrees. Our sine 45 degrees, which is 0.7. We have 0.7 here. Then we also have sine 0, which is equal to 0. So we'll start with the first one. We have 0, 0, the first one. Then we have 90, we have 1. no, before 90 we have 45, we have 0.7, 0.7. Then 90 we have 1. Then 135, 0.7, which is here again. Then 180 we have 0. 225 we have negative 0.7, negative 0.7. Then 270 we have negative 1, which is down here. Negative 1 is here. Then we have 315, negative 0.7. Then 360 we have 0. We move on. 405 we have 0.7. 405 we have 0.7, which is here. Then 450 we have 1, which is up here, have 1. Then we have 495 again, 0.7, and 540 we have 0. So we first plot that. We have that. We need now to plot it. This is our curve. We have the curve this way. From 135, we are moving on to this, to that, to this point, to that one. This is what we have for our curve. Y is equal to sine x. So that's what we have. We name it y is equal to sine x. So that's the first bit. Then we also need to draw the other graph. This is x. We need to draw the other one. Y is equal to sine x plus 45 degrees. So in this case, again, we come and plot now the other points that we have, these ones. So we start with 0, 0.7. Where we have 0, we have 0.7. Then when we have 45, we have 1. 45, here we have 1. It's a bit up here. Then when we have 90, we have 0.7 at this point here. Then when we have 135, we have 0. Then 180, we have negative 0.7. So 0.7 is somewhere here. When we have 225, we have negative 1. So we have our negative 1, the point this. Then 270, we have negative 0.7, which is here. Then 315, we have 0. 360, we have 0.7. 0.7, which is this point here. Then 405, we have 1. 1 is there. We have 1, which is on the same line here. For 405, we have 1. Then 450, 0.7. 0.7, which is this. Then 495, we have 0. Finally, 540, we have negative 0.7, which is the point, negative 0.7, which is this point here. So we have that. Then we need again to join so that we can now describe the transformation. So in this, we are moving from this point here to that, then to this way. Then when we come to this point here, we turn, move on to that, this point. So these are the curves that you are going to obtain. From this again, we move on here, we turn this point, and finally that way. So this is y is equal to sine x plus 45 degrees. So those are the two curves that we are going to obtain for that. We are considering those two, and now we want to describe the transformation. We want to describe the transformation. Now in this, if I may name it again, this is our y is equal to sine x. This is the y is equal to sine x. This is the other one, which is y is equal to sine x plus 45 degrees. Now you can see at any point, this curve y is equal to sine x is leading the other one, that is y is equal to sine x plus 45 degrees, and it is leading it by a certain angle difference here. The angle difference here is 180 minus 35, which is 45 degrees. 180 minus 135 degrees, which is 45 degrees. So we can say that the curve or the wave y is equal to sine x leans the wave at any point. It's the one that is leading. You can see at this point it leans, at this point it leans, at this other point again it is a hand. So we can see that it leans the wave y is equal to sine x plus 45 degrees by an angle which is equal to 45 degrees. So it is leading the other, which is y is equal to sine x plus 45 degrees by an angle that is by 45 degrees, by angle 45 degrees. So we can say in this case, therefore, the face angle, this is the angle which one is ahead of the other by the face angle, therefore, the face angle is therefore equal to 45 degrees. The face angle is 45 degrees in our case here, because one is ahead of the other by 45 degrees. Therefore, we can say to obtain this wave 1 by y is equal to sine x plus 45 degrees. To obtain this, the wave y is equal to sine x will undergo a translation. The wave undergo a transformation, no, not a transformation, but a translation. And this translation is, we have negative 45, 0. That is the translation. This is our phase angle. The phase shift is negative 45. So we are saying to obtain y is equal to sine x plus 45 degrees, the wave that is y is equal to sine x will undergo a translation of negative 45, 0, because this is our phase angle. You've learned more in matrices and transformation on the translation. So we have this undergoing, we have y is equal to sine x undergoing at this translation to obtain y is equal to sine x plus 45 degrees. And therefore we can say our phase shift, the phase shift is equal to 45 degrees. The phase angle is 45 degrees. And we can see the amplitude is the same. The amplitude is the same for both of them. And also for the period, the period again is the same. And therefore we can say that if we have a general equation, if we have a general equation of this form where y is equal to, we can talk of a, then we have sine, let's say we have b plus, or bx then plus c, bx plus c, or we can have it as y is equal to a cos bx plus c. Just to remind you that a is the amplitude. A is the amplitude. Then for our period, we take, and in this case, our A, B, and C are constants. You need to remember that our A, B, and C, these are constants. They are constant. So A is the amplitude. Then when we want to get the period, we'll be given by 360 degrees divided by B. 360 divided by B. Then C, our C here, that is the C, we call it, when we need to have the face, we have the face angle, and our face angle in this case will be C all over B. B can be 1, like in this case, which is 1 here. So our face angle is 45 divided by 1, which is our B. Then when you want to get the phase shift will be negative C. That is the phase shift. In our case here, our phase shift is negative 45 degrees. So that is the phase shift. So that's how we describe this kind of transformation, whereby we have wave y is equal to sine x, leading wave y is equal to sine x plus 45 degrees by 45 degrees. And we say therefore, to obtain y is equal to sine x plus 45 degrees, the wave y is equal to sine x will undergo a translation, negative 45, 0. Then I've said this is our general equation. When we have such, where A, B, and C are constants, our A is the amplitude, then period is 360 divided by B, then our phase angle is C over B, and our phase shift is negative C, depending with the equation. Because if this is negative, if in our case here is negative, we'll have negative 45, negative 45, which will be positive 45 degrees. So that will be the phase shift. But in this case, we have positive, so we have negative C, which will be negative 45 degrees. That's how we describe such a transformation.